Wildcast. Today we're looking at journal page 19, solving 3x3 systems. Solving 3x3 system steps. Step 1, number equations 1, 2, and 3. Step 2, eliminate the same variable from equation 1 and 2, equations 1 and 3, or equations 2 and 3. Number the equations 4 and 5 in step 3. Step 4, now solve equations 4 and 5. Step 5, plug variable back into equation 4 or equation 5 to get the other variable. Step 6, take the two variables and plug into equation 1, 2, or 3. Step 7, state the solution as an ordered pair. Okay, if you would finish up your notes. All right, now your notes are completed. Let's take a look at the examples. All right, step 1, we're going to number the equations 1, 2, and 3. Okay. Now, it says step 2, eliminate the same variable from equations 1 and 2, 1 or 3, and 2 and 3. Well, it looks here like if I multiply this equation by 3, actually, no, we don't have to do that. The 2 and the negative 2 will cancel. So we can just use equation 1 and equation 2. So we have 1x plus 2y minus 3z equals negative 2. That's equation 1. And then 2x minus 2y plus 1z equals 7. And that's equation 2. Okay, so 1x and 2x is 3x. The 2y's cancel. Negative 3y plus 1z, or no, I'm sorry, negative 3z plus 1z is negative 2z equals negative 2 and 7 is 5. And we're going to name this equation 4. Okay, now let's use equation 2 and 3 to eliminate the y. Now, in this case, we need to multiply equation 3 by 2 so the y's will cancel. But there's nothing we need to do to equation 2. So 2x minus 2y plus 1z equals 7. We're going to multiply equation 3 by 2. So that's 2 times 1x is 2x plus 2 times 1y is 2y plus 2 times 2 is 4z equals 2 times negative 4 is negative 8. Almost forgot this is equation 2. This is equation 3 times 2. Okay, 2x and 2x is 4x. The y's cancel. 1 plus 4 is 5z equals 7 minus 8 is negative 1. And this is going to be equation 5. Okay, so now what we have is two equations, 4 and 5, and we're going to now try to eliminate a variable. Now, we probably want to eliminate the z's because we have a negative and a positive, but we need these to be the same number. So we're going to multiply equation 4 by 5 to give negative 10 and multiply equation 5 by 2 to give you a positive 10, so they cancel. So we're going to multiply equation 4 by 5. So 5 times 3 is 15x minus 5 times 2 is 10z equals 5 times 5 is 25. And this is equation 4 times 5. Now we're going to multiply equation 5 by 2. So that's 2 times 4 is 8x. 2 times 5 is 10z equals 2 times negative 1 is negative 2. And this is equation 5 times 2. Okay, 15 plus 8 is 23x. These cancel, equals 25 minus 2 is 23. Well, we know that 23 times 1 is 23, or divide 23 by 23 is 1, so x equals 1. Okay. Now we can substitute x equals 1 in either equation 4 or 5, okay, to solve for z. So I'm just going to plug it into 5 since it's right there. So that's 4 times 1 plus 5 times z equals negative 1. I've been a little consistent in the video. I've been using z's with the line or without the line, but in essence, this is equivalent to this, okay? All right, so we're going to subtract 4 from both sides. We get 5z equals negative 5. Divide 5 by both sides, z equals negative 1. Okay? Now, we need to come back to one of the original equations and solve for y. Okay? I'm going to use equation 3 because there's no number in front of y to solve for y. So, that's 1 plus y equals 2 times z, oh, whoa, not equal, I'm sorry, plus 2 times negative 1 equals negative 4. Okay? So now we combine terms. 1 minus 2 is negative 1, so 1 minus 1 equals negative 4. We'll add 1 to both sides. Y equals negative 3. Okay, so now you're going to state the solution. Let's do that here. So the solution is 1, comma, negative 3, comma, negative 1. Okay, so go ahead and finish up example 1. All right, let's take a look at example 2. Again, we're going to number the equations. Equation 1, equation 2, equation 3. Now we're looking to eliminate in either equations 1 and 2, 1 and 3, and 2 and 3. I don't see anything eliminating in these, but wait. Equation 1 and 3. The negative 2 and the positive 2 will eliminate. So we're going to work with equation 1 and 3 first. So 4x minus 2y plus 4z equals 8. And then that's equation 1. Equation 3, negative 2x plus 2y minus 6z equals 4. Okay, well, we'll see here that 4x minus 2x is 2x. The y's cancel. 4z minus 6z is minus 2z equal 8 plus 4 is 12. And this is going to be equation 4. Okay. Now let's use equations 1 and 2 to eliminate y. So equation 1 is 4x minus 2y plus 4z equals 8. That's equation 1. Now, if we multiply equation 2 by 2, the y's will cancel. So let's do that. So 2 times negative 3 is negative 6x plus 2 times y is 2y. And then 2 times negative z is a negative 2z. And then 2 times negative 4 is negative 8. And that's equation 2 times 2. Well, 4x minus 6x is negative 2x. The y's cancel. 4z minus 2z is a plus 2z equals 8 minus 8 is 0. And this is equation 5. Okay. Now we need to look at eliminating a variable in 4 and 5. So let's look at equation 4. So it's 2x minus 2z equals 12. That's equation 4. And equation 5 is negative 2x plus 2z equals 0. Well, if you look, the x's and the z's will cancel. So cancels. 0 equals 12, and 0 is 12. Whenever the variables are eliminated and you're left with a statement, if it's true, it's infinite solutions. If it's false, like in this case, 0 will never equal 12. It's no solution. All right, so if you would, finish up example 1 and 2, and then start working on your assignment, and have a wonderful Wildcat day.